This is the third factoring video, so if you haven't watched either of the first two, you want to go back and do that. We're just going to be looking at special cases in this one, so it's going to be short and sweet. One of the special cases we've already experienced, and that special case is sort of just a combination of two of our types of factoring. So let's look at the trinomial 2x squared plus 14x minus 36. If you watched factoring video 2, you'll probably want to say, ooh, let's use factor by grouping. But if you think back to the very first factoring video I did on GCF, you can see that this trinomial actually has a GCF. Everything is divisible by 2. So the very first thing that we can do is we can factor out that 2. Now this problem becomes 2 times x squared plus 7x minus 36 divided by 2, which is 18. Now, if we just look at that trinomial that's left over, that's not a trinomial that I have to worry about grouping with. That's just one where I can go, okay, what multiplies to be negative 18 and what adds together to be 7. 6 and 3, nope. 9 and 2, which one would have to be negative to get me a positive 7? The 2. So we can factor that trinomial as x plus 9 times x minus 2, and then don't forget about that 2 we factored out. That's included in our solution. So one of our special cases is factoring out the GCF first, then using one of our other methods. Negative 16x squared plus 64x minus 240. Before you start using your factor by grouping, let's look for a GCF. Chances are, when you have an equation like this, that negative 16 will be the GCF. So open up a calculator and check. Is 64 divided by 16 and is 240 divisible by 16? Yeah, they both are. Now, 16 might not have worked, but you probably could have at least gotten a 2 out of this problem. But since 16 worked, we're going to factor that out. Remember, when you lead with a negative, you're really having to factor out a negative 16. You're dividing everything by negative 16. So then we are left with x squared minus 4x plus 15. Divided everything by negative 16. We need to keep that negative 16, but we can focus on what's on the inside. That's just one of those basic trinomials. What multiplies to be 15 and what adds to be negative 4. Does anything work? 3 and 5, 15 and 1. No. So actually, we're already done. Negative 16 times x squared minus 4x plus 15 is our final solution. We needed to check for that GCF first, though. In this case, it couldn't be factored any further. There weren't any numbers that multiplied to be 15 and added to be negative 4. So that's one special case where you need to factor out the GCF first. Another special case that we've already seen is one where we have only two terms, x squared minus 100. This isn't a GCF problem. This is actually a problem that's a trinomial. This is the same as saying x squared plus 0x's minus 100. When we drew an area model, we saw that this problem works out. We're just looking for things that add to be 0. So if we were to make our table, we're looking for numbers that multiply to be negative 100 and add to be 0. We're looking for opposites. So 100 is a perfect square. That's 10 times 10. If we make one of them negative, we're going to multiply to get negative 100. So our answer is x minus 10 times x plus 10. If we look at another problem like this where we're looking at squares, let's say we had a squared minus 25. This is a difference of squares. we're looking for things that multiply to be negative 25 and add to be 0, because that term cancels out. So we're going to end up with 5 and negative 5. So I'm going to use my blue. So we have a minus 5, and we have a plus 5. Now, if you look at your two answers, you can see that this difference of squares type follows a pattern. So this special case is called difference of squares. If you have a difference of squares, it's the first one and the first one, the square root of it, and the square root of the second number, the square root of the second number. One of them is always negative, one of them is always positive. What's handy about this, though, is that you don't have to use this little special case rule. You can always use one of our other factoring methods to get this solution. So here's one with only two terms, and we just talked about differences of squares. Chances are it's a difference of squares. So I'm going to use my little difference of squares trick to solve this one. 4 is a perfect square, x squared is a perfect square, 9 is a perfect square, and 7 squared is a perfect square. There's a difference, so we can use our trick. I'm going to write my two parentheses out. The square root of 4 is 2, so I need a 2 and a 2. Square root of x squared is x. Square root of 9 is 3. The square root of y squared is y. One of them has to be negative, one of them has to be positive, and we're done. You can use this for any difference of squares. Sum doesn't work, but differences do. So let's say we had 81x squared plus 1. Well, yeah, 81 is a perfect square. So is x squared. So is 1. But it is not a difference. So this is not a difference of squares. This one is actually not factorable. This is the last special case we're going to look at, and at first glance it doesn't look that special. It looks just like one of our regular trinomials. 1 multiplies to be 25 and adds to be 10. 5 times 5. Alright, so when we write our answer, we can write x plus 5 times x plus 5. But we also talked about this earlier. We can write this as x plus 5 all squared. Alright, so let's look at another type of this problem before I give you any solutions or any names for anything. Let's say we had x squared minus 6x plus 9. Again, looks kind of normal. We're looking for something that multiplies to be 9 and adds to be negative 6. Negative 3 and negative 3. So our factors are going to be x minus 3 and x minus 3. Or we can write this as x minus 3 all squared. This is what is known as a perfect square trinomial. A perfect square trinomial is when you have one factor multiplied by itself again. That gets you to your trinomial. You can see that the final number in the perfect square trinomials is actually that number squared, and the middle number is double that number that's in the factor. You don't have to remember this rule. You can factor, obviously, very easily using one of our other factoring methods, but I just wanted you guys to see what it was, perfect square trinomials, when it's the same factor over again. 4x squared minus 12x plus 9. It's got to be one of our special cases. So I'm going to start out thinking about GCF. Is there a GCF out of these? Nope. Okay? So it's not a difference of squares, even though there are some squares in it. So let's go ahead and let's factor this by grouping, just to see what's going on. We have 4x squared plus something times x plus something times x plus 9. According to factor by grouping, I'm going to look for numbers that multiply to be 36 and add together to be negative 12. 6 times 6 is 36, and if they're both negative, do they add to be negative 12? Yes. So I'm going to fill in my blanks with negative 6. Group the first two together and the second two together. We're going to have a GCF of 2x for the first pair. You're left with 2x minus 3. You have a GCF, remember you got to take out that negative, of negative 3 for the second. You have 2x minus 3. So you write down what's the same, 2x minus 3. And what's left over? You get 2x minus 3. So, this was a perfect square trinomial. 2x minus 3 squared is our final solution. Now, we can see that, the first term squared is the first one. The second term squared is the second one. And the middle comes from doubling the product of those two numbers. If you don't want to remember that perfect square trinomial rule, see how easy we did it by using factor by grouping. So keep that in mind, but if you ever hear the words perfect square trinomial, that's what it means, where it's the same factor over again. One of my favorite things to do in the whole wide world is factor. And so I have to throw one last example out at you guys because I just can't stop, and this is going to be my last factoring video. So we need to look at our special cases. Think about our special cases we've talked about today. GCF is the first one. I'm going to look for a GCF. X cubed, x squared, x. They all have an x in them. So let's divide out an x. That's good because I don't know how to factor things with cubes in them. Actually, I do, but that's another project. So x times x squared plus 21x plus 110. That's where we're at now. Well, if we look at that inside trinomial, that's just one of those ones where we need to think about what multiplies to be the last number, what adds to be the middle number. Don't fret too much over that 110. If something that multiplies to be 110 adds to be 21. 110, the easiest thing to me that goes into 110 is like 5 or 10. Let's try 10. 110 divided by 10. That's 11. So I have 10 times 11. Does that add up to be 21? Yep. So we already have this thing factored. You guys are lucky I know my multiplication. So x plus 10 is one factor. X plus 11 is the other. And do not forget that third factor, the GCF. You want to get that written down because that'll be important when we start solving. So 3 special cases were a GCF first, differences of squares, and perfect square trinomials. These are some special rules that help you solve some of these a little bit easier. However, you know that you can always use our other 2 trinomial methods because they are perfectly fine for solving these types of special cases too.